Okay, section 3.3 in Precalculus. So this is the last section for this week's notes. And in section 3.3, we're going to talk about properties of logarithms. So there are several rules when working with logarithms that you need to know. These are basic algebraic rules that you need to know when working with logarithms, okay? So let's see, if I go and I work with, let's go down and look at the rules first. So the first rule is called the product rule. If I have log base b of something times something, then the product rule says that I can break that up into log base b of the first function plus log base b of the second function. So think of these as two separate functions, m and n. So a simple example, if I take the natural log of 7x, remember that's log base e, so we don't say log base e, we say natural log ln, sometimes people will say ln of 7x equals natural log of 7, the first function, plus natural log of x, the second function, 7 times x, okay? So that's breaking up into two logarithms. Now, of course, you can go in the reverse order, right? If I have log base b of m plus log base b of n, and I want to contract this into one log, I would write that as log base b of m times n. Right. Quotient rule, if I have log base b of m divided by n, that means I subtract the two logarithms. So log base b of m minus log base b of n. That is called the quotient rule. So if I have log base 7 of 19 divided by x, that's the same thing as log base 7 of the numerator 19 minus log base 7 of the denominator x. And again, of course, I could go in opposite order. If I have log base b of m minus log base b of n, these bases have to be the same, of course, then I can contract that into one log base b of m divided by n. And the last rule is called the power rule. If I have log base b of m to the power p, then I can bring that power p down in front. So it becomes p times log base b of m. That's called the power rule. So I can use that for something like this, where I have natural log of the square root of x by recognizing that that's the same thing as natural log of x to the 1/2, and that's now a power. I can bring it down in front, so it's 1/2 natural log of x. Or, as another example, log base 7 of 5 to the 4th power, there's a power, bring it down, so it's 4 log base 7 of 5. Okay, so let's use those rules to expand. In other words, broaden out, break up one logarithmic expression into multiple logarithmic expressions, right? We want to use properties of logarithms to expand the following logarithmic expression as much as possible. If possible, evaluate those logarithmic expressions without using a calculator. So sometimes it's simpler to just evaluate them and they look better. Right, log base 3 of the quantity 27 divided by the square root of x minus 2. So first of all, I'm going to use my quotient rule, right? I have a numerator and a denominator. So that's log base 3 of the numerator minus log base 3 of the denominator. Okay, now log base 3 of 27, that's the same thing as saying 3 to what power equals 27. So that what power is 3. So this whole thing is reduced to just 3. And then this is the same thing as x minus 2 to the 1/2. So this is minus log base 3 of x minus 2 to the 1/2. Since I now have a power, I can bring that down in front. So I have 3 minus 1/2 log base 3 of x minus 2. There is no rule to split up this x minus 2. Okay, it's not x times 2, it's x minus 2. There's no rule to split that up. So you leave it as it is. Condensing logarithmic expressions means take logarithmic expressions that are already extracted out or into multiple logarithmic expressions and bringing them down into one. So we want to use properties of logarithms to condense the following logarithmic expression. Write the expression as a single logarithm whose coefficient is 1, and if possible, evaluate the logarithmic expression. So here, first of all, you can't bring logarithms together that aren't the same base. So if you don't see that, stop if these are not the same bases. So here I have log base 4 of 2 plus log base 4 of 32. So because I'm adding two logs with the same base, I can multiply what's in their argument. So that's log base 4 of 2 times 32, which is log base 4 of 64. And I might stop there, but I say to myself, do I know how to evaluate that? What is 4 to what power equals 64? That's what I would say to myself. 4 to what power equals 64? Oh, that's 4 cubed. So the answer, log base 4 of 64, is really 3. Okay, likewise, I can bring these together. So first of all, if I have 1/2 times this sum of logs, I would just distribute the 1/2 to each one of those to begin. Okay, then I say to myself, well, I need to get stuff out of the coefficients. So notice when I have a power in front, I can put it as up to an exponent of the argument. So 1/2 can come up to the exponent of y, and 1/2 can come up in an exponent of x plus 1. So this is the same as log base 5 of x plus 1 to the 1/2 plus log base 5 of y to the 1/2. Then I have a sum of logs where the base is the same, so I can combine them by multiplying. Well, notice I first took the square roots, but then log base 5 of the square root of x plus 1 times square root of y. So it's log base 5 of the square root of x plus 1 quantity times y. That is now contracted into a single logarithmic function of the same base 5. Okay, there's another property called the change of base property that actually allows us to use the calculator. Because the calculator, if you notice, hopefully you've noticed by now, only has a log key and a natural log key. If you just see log by itself, that means that we're talking about log base 10. People don't write log base 10. They just write the word log, and we're supposed to understand that they mean log base 10. Just like if we just see ln, we're supposed to assume that's log base e. We understand that that's natural log. So if you want to evaluate log base b of m, and neither this base b is not 10 or e, you can't do it on your calculator until you use this property. So log base b of m, you can either say that's log of m divided by log of b. Remember, these are base 10. Or you can say they're natural log of m divided by natural log of b. Either one, you get the same result. Okay, the ratio becomes the same. Doesn't matter what base you use, but since we have 10 and e on our calculator, we use those two. So for example, log base 6 of 80 is the same thing as log of 80 divided by log of 6, where these logs are base 10. So then you can use your calculator, try it, evaluate log of 80, divide that by the log of 6, see that you get 2.4457 to the 4th decimal place. Or you could have used the natural log key, where you said this is natural log of 80 divided by natural log of 6. If you plug natural log of 80 into your calculator, divided by natural log of 6, you get the same number. Okay, so let's use our rules, and let's go through and do another example here. Last example. In example 4, we want to let log base b of 5 be some number a, and log base b of 6 be some number c. So these are the same base. So now I want to write log base b of the cube root of 5 divided by 36 in terms of a and c. So what I need to do is expand this guy first. So this cube root is the same thing as to the 1/3 power. So I'm going to bring that down in front. So it's 1/3 log base b of 5 divided by 36. Now I have a quotient, right? So this is 1/3 times the quantity, log base b of 5 minus log base b of 36. So log base b of 5 we already know is a, so I'm going to write that as a. Now I don't have log base b of 36, but I do note that 36 is the same thing as 6 squared, which allows me to bring this 2 down in front of this log. So now I have 1/3 times the quantity a minus 2 log base b of 6. Now I know that this guy is c. So it's 1/3 times the quantity a minus 2c, or 1/3 a minus 2/3 c.